Hey guys, welcome back. I'm really excited today because this arrived. It doesn't say where it's coming from. It does, however, say printed circuit board, and I know what that is. It's a printed circuit board, or actually, I think it's 5. Let's open this up. Now, I have been playing around with my MiniAmp. Actually, let me quickly show it. This is version 1 of the MiniAmp, and my idea was to power it with the 18650 battery cell and being able to charge the battery and not using one of these 9-volt batteries, which eventually will stop working. And I was playing around with this. This is one of these TP4056 charger boards, and it has a step-up module bit on there. The reason I am switching to a printed circuit board for testing, so I'm not sure if this is going to work. The inductor on this step-up converter, that makes some noise, and together with all these wires, it created some noise which I at some point have gotten rid of, and that was just by moving stuff around. But this is not a good test setup, so I decided to make a printed circuit board just for testing. Today I'm going to start with the USB socket and some passive components, and just to see if it all works and I've gotten the correct footprints, because that's a bit of a challenge. I'm using EasyEDA to design my boards, and then I go on AliExpress and try to find the components which have the same footprint as the footprint in EasyEDA. I'm not using LCSC. Yes, LCSC. Just because, you know, usually you can find things on AliExpress a lot cheaper. But quit stalling and shows the board. Here we go. This is the box they come in. Quite used to that now. And what do we have? Well, we have some blue tape, which I'm probably not going to use, but I'm going to put that right there. And these are the boards. Throw away, do not eat. There we go. That's gone. I've chosen white solder mask just because I was interested in how it would look, the white solder mask, and it actually, getting a bit closer, looks quite nice, doesn't it? It's not with the gold finish, it's just the silver type color, because the other one, the gold finish, is more expensive, and this is just a prototype. I'm counting on it that I made a mistake, so it would be quite wasteful to spend a lot of money on this. The first thing I'm going to do is try and solder in this USB connector. Let me grab some connectors. So these are the connectors I received in a recent post bag. Now this whole project can come to a screeching halt if the footprints don't match up. But in case they do, I've got my soldering iron is heating up, and I have some flux, and I'm going to use a very fine needle to dispense some flux and make my life a bit easier. Let's first get one of these connectors out and see if they want to fit. Well, it seems to me that's gonna work. See, there are 2 holes in there, which the pegs of the, I'm calling it pegs, I don't know what it actually is called, of the connector, don't know if you can see that on camera, fit in for some extra stability. And this seems, other way around, seems to fit. And looking closely, also the pins, they are lining up. Well, that's a win. Let me grab some white tack from somewhere to hold the board still, and I'm gonna screw on this needle and dispense a little bit of flux on the pins of the USB connector. And just solder one of the pins. Well, that already made a solder bridge. Let's see if I can clean this up. Well, this is very difficult to do on camera. I have great respect for the guys I follow on YouTube who do this on camera all the time. I can't see what I'm doing. These are all bridging. I just have to move the camera out of the way because I can't see anything. So there we are. I had to do this off camera because the camera is in my way, in my viewing field of view. And I had a soldering bridge between two pins, which I finally removed. Now all I have to do is solder the mounting points to give it some stability, which I hope I can do on camera because it doesn't require me to get in really close. I can't find my tin. There it is. Just move the board around a bit, move it in view. That's one. Turn it around. That's number two. That looks okay. The other side. Yeah, that's fine. So this is the schematic in Easy EDA. It's actually all of this. Today I'm just focusing on this part. As you might have noticed on the silk screen, only the bigger components, like the two MOSFETs, capacitors, inductor, under the chip, which is actually the op-amp, these are labeled. I didn't label the components because I wasn't actually designing a nice looking board. I was just trying to design a working board. So what I've done in EasyEDA is putting the silk screen on another layer. Actually, I think it's a document layer, so that it's not printed on the circuit board, but I can look it up which is which. I'm going to start with the capacitor across the input on the USB side, which is a 0.1 microfarad capacitor, and that's just to smooth out any ripple going into the TP4056 charger. So I have to get that. So here we are, 0603. By the way, all the passive components on here are 0603. 100 nanofarad, which is 0.1 microfarad. So I have to get one out. Get some tweezers. I'm just going to tin one of the pads. That's one side done. It's a bit off to one side, but we'll be fine. That is just terrible, but it's on there. Next, I'm gonna put in the TP4056 charger IC. Again, I have to find that. It's one big mess over here. I should have prepared this, but I was so excited to get this started. Just unwrap the boards and start soldering. Here we go. I found them. Just drop one out. First, let me tin one of the pins. I'm gonna tin pin 1. All I have to do is line it up, reflow the pin, and that didn't go. Do it again. There we go. That's pin 1 soldered, only it's not aligned properly. So I'm just gonna try and nudge it over. Well, the problem is the tip has come loose. I almost went and tightened it, but the iron is on, so this is really hot. So I'm just going to use some pliers and tighten it. There we go. So that's aligned a bit better. I'm just going to solder the opposite pin and then do the rest. So that's all the pins on the TP4R56 soldered. Next I'm gonna do the programming resistor, and on the schematic that is on pin 2, and the programming resistor determines the current or the maximum current the chip charges the battery at. 1.2K. That is directly from the data sheet. Let me grab that, and that's over there, means 1 amp. I'm gonna go with a larger value of a resistor just to charge the battery at a lower current to make sure I don't overcharge, or when I'm charging the battery and some fault happens, there's not an amp flowing to the battery, but a bit less. Makes the charging time longer, but it's just a bit safer in my opinion. So I'm gonna go with a 3K resistor that charges the battery at 400 milliamps. Here we are, a 3K resistor. Now let's check. That looks to be okay. So the next thing I'm gonna do is solder in the 2 LEDs which indicate whether the chip is charging a battery or whether it's charged and standing by. These use 1K resistors, and theoretically I could then charge a battery without the use of this part of the circuit, which is the protection circuitry. And just to be safe, I'm gonna use a protected cell which already has this protection circuitry on the battery itself, and we should see this somewhat working. So I've soldered in the 2 LEDs. I didn't have a green one. I thought I did. Can't find it anymore, so I used the blue one. The other thing is, looking at the schematic, I also need this capacitor over here, which is a 10 microfarad capacitor between the charge output and ground. And if I look at the data sheet, that would mean that if there's no battery connected, but there is the 10 microfarad capacitance, the green LED is going to be on and the red is coruscate, I think pulsating, which is going on and off. We'll see. But this way we can test this board without actually connecting a battery and just seeing whether the 4056 charger is working. So I'm going to solder that on. It's this one over there, and then we can connect 5 volts and see what happens. So the moment of truth, will this go bang, or will there be any smoke when I plug in 5 volts to this board? Well, there's only one way to find out, and I'm just gonna do it. And an LED comes on. it is the blue LED, which should be green actually, but I couldn't find that, so I used blue. The red LED is pulsating, or coruscate, that's how they call it on the data sheet, but you can't really see that because the blue light is just swamping out the camera. But maybe if I change the angle, you can see the red LED, which is an indication that there's no battery present. So the next thing, I'm gonna solder on the battery connector and actually put in a battery. So here we go, the battery connector is soldered on. What I did forget to do when making the footprint for this connector is put a marking on the silk screen where the positive and negative of the battery need to go. Now I know, because I'm looking at the schematic myself, that the battery positive goes on this side. So before I forget, I'm just gonna add a positive and a negative marking on the PCB for future reference. Just gonna use one of these markers and just mark it over there, so I know that is the positive. And I'm also going to add the board marking to the bottom silk screen. Just going to use text for that and add some text. It actually needs to be a plus symbol. There we go. And I'm going to put that over there. And well, this should be enough because there's only one positive. Just gonna mark one of them as negative. There we go. And I'm gonna put that over there and save. So I'm gonna use one of these protected cells just to be safe, and also because there's no protection circuitry on there yet. So just gonna put that in, positive, negative, negative, positive. It does require some convincing to go in, but it does go in. And now I'm gonna plug in 5 volts and see what happens. So I know what I've done wrong. Me thinking bypassing the protection circuit on the board and just using a protected cell would work. I'm forgetting, when I look at the schematic, that the battery negative is not directly connected to ground. Instead it goes to dual MOSFET, which is controlled by an over-discharge and an overcharge chip. So these two MOSFETs are currently off, or in their non-conductive state. So the battery negative doesn't make a direct connection to ground. That means I can't charge it. And if I take my multimeter and set it to continuity, and I'm just gonna make sure I'm not plugged in. So what I now need to do is to measure the continuity between the ground pin, which is pin 3 on the chip, and the negative terminal of the battery. And that should show no continuity between the two. And there is no connectivity. So there's no complete circuit. So the TP4056 doesn't see a battery. So I do have to fit the over-discharge and overcharge IC and the dual MOSFET with the complementary passive components to see whether this is working. I'm not going to do that right now. Thanks for watching. I'm going to do that next time. For now, we did see some LEDs blinking.